Hello, Mark. You're from the EPCC, Edinburgh Parallel Computing Center.
That's right.
So we're here at OpenMPCon, and thank you very much for your insightful presentation on tips, tricks, and gotchas.
Oh, you're very welcome.
Yes, and you're evangelizing for people to use default none, for instance.
Absolutely, yes. I think it's so. Unfortunately, it was maybe one of the really bad decisions that was made in the very, very early days of OpenMP. So it's a really important tool to use to make sure that you don't get race conditions in your program. Yeah.
So we advise the users.
Always use default none. And I always say, and I mean it, no exceptions. And I have no sympathy with my students if they don't do it. Right?
Okay, so at the EPCC you come across a variety of applications using OpenMP.
Sure, we do. Yes.
Yeah. And can you describe one of the applications, a use case? Where OpenMP is used?
Yeah, so something that's really quite an unusual application is one that a student and I have been working on for the last couple of years or so, and it's an application for pensions companies. They need to do the calculation to figure out do they currently hold enough reserves to meet their obligations for all their pensioners. And some of these pensioners companies are very big. They may hold 500,000 pensions for pensions for 500,000 people, and they need to do basically a large Monte Carlo simulation. So they need to take into account the fact that interest rates may vary in the future. So that's one unknown, and another unknown is they don't know what the mortality rate of people. They don't really know in the future how fast people are going, how long people are going to live, and what the mortality is going to be. So they need to do this large Monte Carlo simulation, which is quite expensive. And the solution we've come up with is a hybrid solution. So at the outer level for the Monte Carlo part, we use MPI, and we are using. They need to do 1,000 Monte Carlo scenarios, so we can use 1,000 MPI processes because that part's essentially trivially parallel. But we'd like to get some more parallelism out of that. So we then, inside every MPI process, we use OpenMP to exploit the parallelism over the different policy holders. So there's a second layer of parallelism there we can use, and it's convenient to use OpenMP for that for a couple of reasons. So there is some dynamic load balancing required. That's essentially because the amount of work that you need to do for one particular policy depends on the current age of the policy holder. So the older you are, the less computation we need to do, because the sooner we know you're going to be dead. So that's nice. And the other thing we do is we also try to exploit vectorization. So we use a blocking strategy, and we are using the new OpenMP SIMD directives to enable the vectorization. So essentially we have these three levels of parallelism that we're exploiting here. And it's really nice. A lot of the work we've done is to improve the algorithms, but essentially what we've gone from is a case which in the industry, using industry standard software, is completely computational infeasible, to something that we can solve on a few thousand cores in about 10 minutes.
So this is from the financial world.
Yeah.
This is a problem that is also existing in the financial world?
Yes, absolutely. So it's essentially a regulatory requirement. So the financial regulators will require that the financial companies do this calculation to prove that they have sufficient reserves. To prove to the regulators that they are holding enough reserves, and
especially in the aftermath of the
the crisis, the 2008 crisis. Yeah.
So and since they will have to do this calculation.
They will have to do this.
Your method can be used.
Will enable them to actually do it. At the moment, they're just holding their hands up and saying, we cannot do this.
Yeah.
This is impossible. This is absolutely impossible.
Yeah, yeah. So this is a very valuable contribution to the financial industry.
We hope it will be.
Yes. Okay, great. Well, thank you very much. Yeah, that's for your time. Yeah, it's a nice
You're welcome.
example.